Today the topic for discussion is significant figures. This is the topic of the chapter errors, first chapter errors. So what is the definition or meaning of significant figures or significant digits? So the number of digits which are used to express the number are called significant figures or significant digits. For example, this number 2.7182. So how many digits are used to express this number? 5. Okay, so that is 27182. These are 5 digits, and therefore significant figures in this number are 5. Okay, similarly, the digits used to express this number are also 5. Also, all these numbers. So this 0 is not counted in this expression, because we can write this number as 0 point or just 0.2718. That's why the 0 is not counted. So the number of digits used to express this number are what? Are 5. So all these numbers are having significant figures or significant digits equal to 5. Okay. So here is the data of number and significant figures. So the significant figures in this number are what? 5, because 5 digits are used to express this number. Okay. Similarly, the significant figures for this number 0.1234 are 4. 0 is not counted in the significant figures. Okay. So this 0 is counted in this significant figures in this number. Okay. So the number is 3.08, and the number of digits used to express this number are what? Are 3, and therefore significant figures of this number is equal to 3. Okay. So significant figures for this number are what? 6. Significant figures for this number 0.0028. So this number also we can express 0.28 into 10 raised to minus 2. That's why this significant figures in this number are 2, because no need to write this 0, also this 0 after this dot after point. Okay, we can write this number as 0.28 into 10 raised to minus 2. That's why the significant figures are what? 2. The significant figures in this number is 1, because we can write this number as 0.9 into 10 raised to minus 3. Similarly, we can write this number as 0.425 into 10 raised to minus 4. And that's why the significant figures in this number are 3. So there are some numbers which are which we cannot decide the significant figures in that numbers. For example, some numbers we cannot write the significant figures for that number. So this number 3.853.0. Okay, so we can write this number as 3.85 into 10 raised to 5. Okay, or we can write this number as 3.850 into 10 raised to 5. Okay, that's why these significant digits are what? If we write this number in this form, then significant figures are 3. So this number has 3 significant figures. If we can write this number in this form, 3.850 into 10 raised to 5, then significant counts is what? 4. If we write this number, we can write this number in this form. Then significant figures are 5, because we have 5 digits in this number. So if we can write this number in this form, then significant figures are 6. So we cannot decide significant figures in this number. So there are some numbers in which we cannot decide the number of significant figures. The next is round up the number. So we can round up the numbers by using these rules. The first rule is what? Suppose we have to discard all digits right to nth digit. So we observe the n plus 1th digits of that number. Suppose we have to discard all digits after 5 decimal places, 4 decimal places. Then what is the procedure of round up the number? We observe n plus 1 place discard number. If it is 5, less than 5, then leave the nth digit unaltered. That is, leave the nth digit as it is. That is, if the n plus 1th digit is less than 5, then remain nth digit as it is. If the discard digit, that is the n plus 1th place digits, is greater than 5, then increase the nth digit by 1 unity. By unity means by 1. That is, if there is at the nth place, if there is 4, then write 5. If there is 3, then write 4. That is increased by nth digit by 1. And if the fifth, the n plus 1 digit is exactly 5, then what is the rule? If the previous number is odd, that is, if nth digit is odd, if n plus 1th digit is exactly 5, and if the nth digit is odd, then increase it by unity, by 1. And if the nth digit is what? Is even. Obviously, n plus 1th digit is exactly 5, and if nth digit is even, then leave nth digit as it is. That is unaltered. Okay? That is, if the n plus 1th digit is exactly 5, then there are two rules. The previous digit is odd, then increase by 1. And if the previous digit is even, then remains the digit as it is. Okay? So the application of these rules in these examples. So the question is what? Round up the following numbers up to 4 significant figures. So if you count the significant figures in this number, how many significant figures in this number? 1, 2, 3, 4, 5, 6, 7. So there are 7 significant figures in this number, and we have to round up this number to 4 significant figures. That is 1, 2, 3, 4. So up to this, what we have? We have the 4 significant figures, and so we have to discard the afterward digits. That is 5, 6, 7. We have to remove this 5, 6, 7 from this number. We have to delete this 5, 6, 7 from this number. So what is the procedure? This number is 5. That is exactly is what? Is 5. So, and the previous number is what? Is even. So no change. If this number at this place, if the number is greater than 5, increase previous number by 1. If the number is less than 5, then remains the previous digit as it is. But if the number is exactly 5, that is the third rule is applicable for this example. That is the discard digit is what? First one digit is what? Discard first one digit is what? Exactly 5, and even the previous digit is even. So no change in the previous digit. So okay, and so this is the new number 1.234. This number is rounded to 4 significant figures. Also, we have to round up this number up to 4 significant figures, and this up to this we have the 4 significant figures. That's 10.34. But how we can write this number? The next digit, we have to discard digits from 6. All digits from 6. That is, we have to discard. We have to remove the 6 and 7, because we have to round up this number up to 4 significant figures. And this number is what? The discard first digit is what? Is 6, and that's why we increase the previous digit by 1. That is right in the place of 4, 5. Okay, that is this second rule is applicable. If the discard digit is 5, discard digit, first digit is 5, is greater than 5, then increase the previous digit by unity. So we have to discard this 6 and 7. So the first discard digit is what? Is 6, that is greater than 5, and so increase previous number by 5. And we have to round up this number again up to 4 significant figures, and the 4 significant completes here at this place. Okay, and the digit is what? The discard first digit is what? 5, exactly 5. So if the previous digit is odd, then increase by 1. So the discard digit is what? Is 5, and therefore increase and the previous digit is odd. So by using this rule, third 3A, what do we have? So we have the number 9876. Okay, that is the discard first digit is exactly 5. Then if the previous digit is odd, increase by 1. If the previous digit is even, then remains as it is. Okay, so here is the previous digit is what? 7. So here is the previous digit is what? 7. And so here, for example, we have to 7, and therefore 9876. We have to discard the digits from this. We have to round up this number up to 4 significant figures. That is, we have to remove this 6, and this 6 is what? Greater than 5. So increase the previous number by 1. 5 is replaced by 6. After this number 9875, and the next digit is what? Is 5. We have to round up this number up to this. We have to remove this 5. So this 5 is what? This is exactly 5, exactly 5, and the previous digit is what? Is odd, so increase by 1. If the discard first digit is 5, but the previous number is even, then no change in the first example. So here the third A is applicable. Third A, 9876. So round up to 4 significant figures. And so we have to round up this number up to 4 significant figures. That is 9875, and we have to remove this 4. So this number is what? Is less than 5, and therefore the previous digits remains as it is, because the digit is less than 5, then leave the previous digit unaltered as it is. Okay, so all these numbers are round up to 4 significant figures. So here is the question: round up the following numbers to 2 decimal places. Here is the decimal places. So two decimal places. 2 decimal places. So the first number 4.4821. So here after 21, we have to remove all digits, because we have to round up the number up to 2 decimal places. So we have to remove or discard the digits 4, 1, 6, these 3 digits. And the first discard digit is 4, and that is less than 5, so remains the previous number as it is. Okay, so you have to remove from this number 4, 2. So the number is what? First discard digit is 4, less than 5, so no change. 2.37 is the round up number. So here we have to discard the number after 7. That is, we have to remove the number only 5. And if the number, the first discard digit is exactly 5, and the previous digit is odd, then increase by 1. So it's become 28. And here we have to remove this 5, and if the first discard digit is exactly 5, and the previous digit is even, then no change. So the number rounded to 2.38. So this number rounded to 81.25, 26, because this number discard digit, first discard digit is 5 and the previous digit is odd, so increase by 1. So all these numbers are rounded to two decimal places. Round up the following numbers to four significant figures. So these are the numbers, and we have to round up these numbers up to four significant figures. So the first number, remove this 2, 3, 5, and the first digit is what, 2, less than 5, so no change. Similarly, this number rounded to four significant figures. This number also rounded to four significant figures. So here the four significant figures are completed. So we have to remove 8, and so it is greater than 5. So increase the previous number by 1. So we have to round up this number up to four significant figures, means we have to discard 5, 1, 0, 1. So this 5 is what? Exactly 5 number, and the previous number is odd, so increase by 1. Increase the number by 1. So 19.24. Here is a mistake. We write here 19.24 because the previous the discard digit is what? Exactly 5, and the previous digit is what? Odd, so increase by 1. Here is the correction, right? 19.24. Similarly, here is the number 2 less than 5, so no change in the previous digit. Okay. So next problem is calculate the value of root 102 minus root 101 correct to four significant figures. So by calculator, value of root 102 is this, and the value of 101 root 101 is this. Okay, by using calculator. So write all digits after point in the calculator. So if there is a calculator of 9 digits or 10 digits, then we have such a figure in that calculator. So we write that subtraction. This is the subtraction by using calculator. Okay, and we have to correct to four significant figures. So what is the question? Correct to four significant figures. So we have to round up this number up to four significant figures. So we have to round up this number up to this 2. Okay, so we have to remove this 93173. Okay, so this number is what? The first discard digit is 9, that is greater than 5, so increase the previous number by 1. So this is the answer correct to four significant figures. Okay, so next. So this is the upper limit for absolute error. What is the upper limit for absolute error? Upper limit for error, that is equal to round up the number, then the absolute error or upper limit for error is delta x is 1/2 10 raised to minus n. So how we can understand this formula? Suppose this is the number 38.46235, and we have to round up this number to four decimal places. That is, this number is rounded to four decimal places. Okay, so what is the answer? 38.4624, because this number is 5 and the previous number is what? Is odd, so it increased by 1. And so what is the difference between these two? Is point not 5. If we subtract this number, this first number from the second number, then we get answer point not positive, not 4 times not 5. Okay, so also this number is rounded to four decimal places, and then we have this difference point not 3. This number is also rounded to four decimal places. We have the answer positive point not 349. That is point not something 4 times not. This number is also rounded to four decimal places, and their subtraction or their difference is what? Point 4 times knots and 5 and something. Okay, so if we rounded the number to 4 decimal places, if we round up any number up to 4 decimal places, then the highest difference is what? Point not 4 times not 5. Okay, so how can write this? That is the upper limit. This is the upper limit of difference or error. Difference means error. So what is the upper limit of error? If the number is rounded to 4 decimal places, is point 4 times not 5. So here is the formula. If we rounded the number to n decimal places, then the upper limit for the error is 1/2 into 10 raised to minus n, and it's called is the absolute error. Error. We can say it is error. Absolute error means we just say error. What is the error? Actually, this is not actual error, but it is upper limit of error. So highest error, if the number is rounded to n decimal places, is 1/2 10 raised to minus n. How this formula working? See this example, that this number 0.25 is correct up to 2 decimal places, rounded to 2 decimal places, and then what is the formula? 1/2 delta x is 1/2 10 raised to minus 2, 2 decimal places. That is point not 5. This is the actually upper limit or error in this number. So what is the error in this number? If this number is rounded to 4 decimal places, is point not 5 and something. Okay, so if we rounded the number up to 4 decimal places, here is the some examples that these numbers are rounded to 4 decimal places. So what is the highest or upper limit of the error? Is point 4 times not 5. So actually this is the upper limit of the error, or we can is called absolute error. So what is the absolute error? The number is rounded to n decimal places, and the upper error is what? Or absolute error, that is denoted by delta x, is what? 1/2 10 raised to minus 1. So by using this formula, if we count the absolute error, if the number is rounded to 4 decimal places, then we have the answer 1/2 10 raised to minus 4. That is 0.5 into 10 raised to minus 4 means what we have? The answer 4 times not point, after point we have 4 times not 5 and something. Okay, uh, that is the upper limit of absolute error or error if the number is rounded to 4 decimal places. That is the formula is what? If the number is rounded to n decimal places, then absolute error that is denoted by delta x is 1/2 10 raised to minus n. So we see some examples on this formula in next lecture.